Hi folks, today I want to talk to you about protocol buffers and gRPC. Protocol buffers and gRPC are a way to provide a clean interface for a client and server to communicate, and protocol buffers provide the underlying implementation. But before we get into how to use them, let's talk about what the alternatives are. Commonly you'll see things like HTTP or REST APIs. REST just means representational state transfer. It's a complicated way of saying that the request embodies all the information that's needed for the server to evaluate that request. To make this more concrete, let's look at an example. Here I'm going to pull up the Slack API, and let's go to Reference, and let's look at the Web API and API methods. As you can see, there are a ton of API methods that Slack provides. For example, if I want to delete a chat message, I can go to this chat.delete function, and here you can see that the URL is slack.com/API/chat.delete, and basically what this means is if your application sends an HTTP post request to this URL, and you provide these headers, and you provide certain information, for example, the token, channel, all of these are required parameters. If you pass this information in, Slack will be able to process your request. And as you can see, there are a ton of these methods. You can do something like update a chat message, you can kick people out of conversations, you can open new dialogues with users, you can adjust do not disturb settings, and so on and so forth. There are a ton of Slack API methods here. The issue with this is that it all depends on human documentation, and that if I want to figure out what methods are available, I have to go to this api.slack.com website, I have to read the documentation, I have to figure out what the URL is, I have to code this into my application, I have to figure out what the arguments are, and so on and so forth. And if something changes, it can often be really hard to debug what's going on. Protocol buffers with gRPC, on the other hand, provide a clean way for you to specify to an application what API methods are available. So to do that, let's take a look at an example. Here I'm just going to open up a new example.proto file. A protocol buffer file contains a bunch of definitions that are used to describe what service a server provides. So let's just start writing an example. So to start, the first line is usually a syntax definition. This specifies the syntax line specifies which version of protocol buffers you're using. Here I'm using protocol buffers version 3, which is the latest version. Next, I can specify a package. The package is important because if you have multiple protocol buffer files in the same folder, the names may conflict with each other. So in this example, I'm just going to say I'm in the package example. So here, all messages need to be unique within the example package, but it's okay if messages in different packages have the same name. So let's write a first message. Often, since we're describing a remote procedure call, you will have messages that are requests and responses. And the client generates a request, sends it to the server, and the server replies with a response. So in this case, I'm just going to write down a request. In this case, I'm going to say that the message hello world request contains a string text. So here I'm saying string text equals 1. The 1 is just a numbering of the fields in the protocol buffer message. And this is needed because sometimes when you decide to update an API, you may want to change what fields are available. And when you do this, you should ensure that you're always using new numbers for the field descriptors. That way, if people are using the old version of your API, there won't be any mistakes. Now let's say I want to change this protocol buffer later, and I say that this should become an integer, so a 64-bit integer called none. Anyone using the old version of my code, which had the string text equals 1, will get confused because they're trying to send a string object in the field number 1, whereas the server is expecting a number, a UN64. So best practice is to use new numbers for your protocol buffer fields. So in this case, I can give the number a field number of 2. But let's go back to my example. I'm just going to put that back, string text equals 1. And normally you'll number these numbers sequentially, so the first field will be 1, then 2, then 3, and so on. But, if you need to change your protocol buffers, it's fine to use non-sequential numbers. There's certainly no requirement that the numbers be sequential. Okay, now that I've written a request, let me write out a quick response. So, hello world response. And let's say the server also replies with a text. So these are two very simple messages. Now I need to define how the server interacts with these messages. And to do that, I'll define a service that my server will provide. So I can say service, hello service. It's common practice to end your service name with service. So in this case, hello service rather than just service hello or something like that. And then I open curly braces. Now it's time to specify what methods my server will provide. So in this case, I'll just have a single RPC, a remote procedure call, called hello world, that takes in the argument hello world request and returns a hello world response. And that's all the methods my service would provide. Okay, so basically this just says that I will have a server called hello service with one RPC called hello world that takes in a hello world request and returns a hello world response. Now, you know that there are parentheses around the hello world request and response. Typically, you can only have one argument to the RPC. So it won't work if I wanted to say something like hello world request. So if I wanted my service to actually take two arguments like this won't work. The RPC only expects one argument. So if I wanted to add fields to the argument, I would have to add it in the message. So I could say string text2 equals 2, for example. But I don't need this for now. So that's all I want to write for now. So I will just save this file. Now I want to implement a server in Python. So to do that, I need to generate Python code from this protocol buffer file. The way gRPC works is that you write your protocol buffer file, as I just did, and then you can compile it into many languages. You can compile it into Go, Java, C, Python, PHP even. But for this example, I'm going to use Python. So to be able to generate Python code from your protocol buffer description, you need to install a few things. I'll link to this page in the description, but you can install Python and you'll have to install gRPC IO and the gRPC tools. Once you've installed gRPC tools, you'll be able to generate the gRPC files by following this command. So let me just copy and paste the first part. Okay, so once you've done that, you can specify an input directory, which is the file location from which all your imports are relative. For now, since the protocol buffer file is in our current directory, we'll just put in / for the current directory. Then you need to specify the location of the output. So in this case, since we're compiling to Python, I'm going to type python out equals, and I want to generate that the output in this directory, so I'll put dot. If you also want to serialize more than the messages, if you want to serialize stubs and servicers for the client and server, which I'll talk about later, you also need to do gRPC python out equals, and again, I'll output the result in this directory. Finally, I need to specify which protocol buffer files I actually want to compile. So in this case, that's just example.proto. And I was in the wrong directory, so let me just change directories. Now if I run the command again, you can see that it's generated two new files, example.pb2.py and example.pb2.grpc.py. The gRPC.py file contains all the gRPC related stuff. So all of the common code, that is all the messages and their definitions and all, will be in example.pb2.py. And all of the gRPC related stuff, the servicer, the client stub, etc., will be in the gRPC.py file. So let's just take a look at what they look like. So if I look at it, it has some imports. It's not really easy to look at this, but you can see that I've generated a hello world request, a hello world response, and a bunch of a service description for the hello world service, right? Okay, so now I can also look at the gRPC code. So looking at the gRPC code, you can see that there's a hello service stub. This is what the client will use when it wants to talk to the service. Essentially, you take the stub and you can call methods, in our case, hello world, and you'll give it the hello world request and it'll give back the hello world response. So that's what the stub does. The servicer is the object on the server. So when you write a server, as we'll do shortly, the server implements this servicer class and overrides, the hello world function. You can see that by default, the hello world function is not implemented and throws an error. But when we write the server, we'll implement this method so that it actually handles the request. Okay, now that I've generated the protocol buffer files, I want to actually write the server. So to do that, I'm going to create a new Python file called server.py. I'm going to start by importing something. So I want to import gRPC. I want to import the two generated files. So import example pb2 as pd, and import example pb2 gRPC as, let's say, pd gRPC. Now I need to define a servicer class. The servicer class essentially provides all of the functionality that the server stated it would provide in the protocol buffer files. So to do that, I'm going to say class hello service servicer. Now to override the methods that you saw in the generated protocol buffer files, I want to make it a subclass of the generated servicer class. So that was, if you recall, in pd_grpc.hello service servicer. Right, cool. Now I want to define the first RPC, which was hello world. So I'm going to say def hello world. It takes in self, because this is a Python class. It takes in a request, and it takes in something called a context, which we'll ignore for now. There are also some other optional arguments, but we'll ignore those. So in this case, I want to just say hello, comma, and whatever text was sent in the request. So let's say something like reply equals hello and request.text. Cool. Now that I've calculated what reply I want to give, I actually need to package this into a gRPC request. Sorry, a gRPC reply. So to do that, I'm going to create a new hello world response, because if you remember, the protocol buffer file stated that we need to return a hello world response. So to do that, let's just do response equals pd.hello world response. Again, we're using the generated classes here. And the first parameter was text. So in this case, the text we want to return is the reply, like so. And now we can just simply return the response. So we need to actually set up the server so that it listens on a port and waits for anyone to send it a request, and then it can send a response back. So to do that, I'm just going to copy paste the code from the Getting Started guide, which I'll link in the description. So I'm just going to copy this. Let's go to and let's paste this. Then I'm just going to get rid of some stuff that we don't need. So I'm going to get rid of logging. We'll change this to pd gRPC. I'll add hello service servicer to the server. This will be hello service servicer. And we can keep this the same, basically. So this just says that we're going to listen on port 50,051. Then we start the server and keep it running until someone stops the program. So this should be fine. I also need to import from concurrent import features. This just says that we can create 10 workers simultaneously. So we can have up to 10 requests being processed in parallel. Note that these are threads in Python, so only one thread can perform Python code at a time due to something called the global interpreter lock. But this isn't a problem in our case because there's not much compute we're doing, and most of the time threads will be waiting on I/O, so sending out a request, receiving a request from the network, or writing it out to reply. So we don't need to worry too much about the global interpreter lock. But if you're interested, or if you're writing Python services that do a lot of computation, you might need to worry about the global interpreter lock. And the solution, if you have compute-intensive tasks, is usually to use processes instead of threads, because processes each have their own interpreter lock rather than threads, which all share a common one. So I won't go into too much detail on that, but if you're using compute-heavy tasks, you may want processes instead of threads. But for our purposes, threads are just fine. Okay, now let me save that, and now let's open up a client. So the client has to talk to the server and get the server to perform whatever methods it wants. So to do that, to set this up, I'm just going to import gRPC. I'll also import the example files that we generated. So example pd2 as pd, and import example pd2 gRPC as pd gRPC. Now, to communicate with the server, we need to establish a connection to it. And in the Python version of gRPC, the connection is something called a channel. So a channel is basically a connection to the server, and once you're done with it, you need to close it. However, Python provides this nice syntax which is a with block. So essentially, we can do with gRPC dot insecure channel, and we'll provide us the address we want to connect to. In this case, it's localhost 50,051, since we're connecting to the server running on our local host and on port 50,051. And let's give this a name. Let's call it channel, ch for channel. And so the with clause basically will close the channel once it exits the with clause, so we don't need to worry about manually closing it. Now we can create a stub. The stub allows us to connect to the server, send it a request, and retrieve the response. So we don't have to worry manually about setting up a connection and then sending data on the connection and then receiving data. That's all handled by the gRPC code. So what I can do now is I can just say stub equals pd gRPC dot hello service stub, and I'll give it the channel. Now, once I've done that, I can create a request that I want to send to the server. In this case, my request will be a hello world request, hello world request. And so recall that it has one parameter text, which I'll set equal to a string hello world, let's say. And now I want to send this to the server, so I can simply do stub dot hello world request. And this will return a response, so let's say that as a variable, response equals that. And now let's just print out what we got. So received, and let's put in response.text. Cool. So now let's try running this. So I've opened up a new terminal. I'm going to run my server. So I'll run python server.py. And now you can see that this is not exiting. And that's as intended, because our servicer is just listening on a port and waiting to receive any requests. So this will just run until you stop it, and you can stop it by typing Control-C, and there you'll see it was interrupted. But for now, we want to leave our server running. And now in my other terminal window, I will run the client, so python client.py. And you can see it receives hello world. So awesome, we're talking to the server, and we're getting the response hello world back. Okay, now before we wrap up, I want to talk about one other feature of gRPC, which is imports. Sometimes you may want to reuse message objects across multiple services. For example, if all of your services have a common conception of what a user object is, you might want to share that user object in a common file and have each service import that user definition into its own protocol buffer messages. So let me show you an example. So let me stop the server. So I have this example.proto file. I'm going to make a new protocol buffer file called user.proto. And I'm going to create a, first let's set up the syntax. Let's say it's in package user. And let's say it has message user with a single name, string name equals 1. So let's save this and quit. And now let's go to my example.proto. And let's say I want to make a new RPC, let's say RPC hello user, that takes in a hello user request and returns a hello user response. Now I want to be able to reference the user object that I defined earlier. So the way I can do that is by adding an import statement. So I'm going to, in this case, import user.proto. So this says, look in the current directory relative to the input directory and look for a file named user.proto, and then import all the message definitions into it. So this will just find the user.proto file we defined earlier and make that user message available to us. So now let's write out some more requests. So message hello user request. And let's say it takes in just a user. So since the user was in the package user, I'm going to type user.user person equals 1, and that's it. And then let's say the hello user response just returns some text. So string text equals 1. Cool. So to recompile the files, I'll run again python-gen gRPC or proto. The import directory is the current directory, and I want to do python out equals dot and gRPC python out equals dot. And now I can give it two files instead of just one. So I can give it example.proto, and I can also give it user.proto. And I've said gRPC.proto instead of gRPC tools. So let me just change that, gRPC tools. And now if I ls, you can see that I have some new files. I have this user.userpb2.py and this userpb2grpc.py. Technically, I do not have generated the grpc.py file because the user.proto file does not generate any service definitions. So in fact, we can just look at it and see what's in it. So in fact, if you look at the generated file, it's empty. So I'm just going to delete this because we don't need it. Okay, cool. Now let's modify our server to use the new definitions. So server, we added a new method called hello user. Again, it takes in a self, request, and context, which we'll ignore. And in this case, we want to say hello to that user. So in this case, we're going to say hello, and the request has a user object, and the user object has a name. So in this case, we'll use request.user.name to address the user. And then we can just copy this and do the same thing. Of course, this time we're returning a hello user response, and this should just work. So let's modify our client to say hello user rather than hello world. So we'll do this, and then I will change the request to be a hello user request. But this actually needs a user object. So to do that, we're going to import user pb2 as user. And now we can say our user object is equal to the user pb. Let's rename this to user pb. User pb dot user and name equals me. Cool. And then let's say the person is equal to the user. And now we want to say, instead of hello world, we want to say hello user. Cool. Now let's again, I'm going to run the server in one window, and you'll see it doesn't exit. And then in another window, I'm going to run the client. So python and .py. Okay, so you can see that hello user request is not defined. That's because I forgot to do prefix it with pd. Now you need to ask yourself which protocol buffer file contains the hello user request, and the answer is that it's going to be in the example pb2 file, which I've imported as pd. So I'll just do rec equals pd. Pd dot hello user request. Cool. Now let's try running this. Okay, so I found that I made a mistake in the server. So it's remember that we didn't call this field user, we called it request.person. So let me just change that. And let's restart the server. And now it's from the client again. And cool, it says hello me. So that's how you can share messages between protocol buffer files. I hope this was helpful. Let me know if there are any other questions or if you want me to cover more advanced topics.